the key thing to remember is that all software is a tool to do your job. And Leapfrog, talking about that specifically, is a tool for building geometries first and foremost.
Right.
And geometry modeling is not geological modeling.
Today I'm speaking with Mike Stewart. Mike is my first guest in person in the studio here, and he lives in Christchurch and he's flown down to come and have a chat to us. Mike is the technical domain expert geomodeling with Seequent. So obviously a great place to talk about everything domaining, resource estimation, software. So lots of interesting topics. Hope you enjoy. Let's get into it. Hey Mike, how you doing?
Good, thanks René.
Hey, thanks for coming in. You live in Christchurch?
Yep. Been there for 7 years now.
So it's exciting because that's the first time we have somebody in the studio to talk to. So
yeah,
that's
always like an excuse to come to Dunedin.
7 years. So what is a resource geologist with your background do in Christchurch?
Well, you go to the dark side. Begin working in software and software development, which is quite a change in career, but drawing in all of my existing expertise into that.
Right. So tell me about your career a bit. How did you land in resource geology? I mean, we had in a previous episode we talked about how do you get to be a resource geologist, right? For the younger crowd, how does one land a job in resource geology, and then how do you move into the dark side by choice, obviously? But what's that pathway look like?
It looks like a classical geology degree, so very much a stratigraphy structure, geological degree training, followed by a thesis.
In New Zealand?
In New Zealand, yeah. So I did my thesis in the Cobb Valley on early Cambrian strata structure.
Nice.
Which was fascinating. From there, I spent a couple of years working in mud mining on the west coast, alluvial mining, where I learnt a lot about life and all sorts of things, including geology. From there to the UK, where I ended up working for the Geological Survey, the British Geological Survey, mapping, coalfields mapping, in the thematic mapping.
And they paid you to
section.
map. So.
They paid me to map. It was interesting because some of that mapping was going over mapping that had been, or was repeating the mapping for the fourth time. Okay. And the early geologists in the 1830s did a really good job. So it was tweaking the boundaries. It was no groundbreaking discoveries, but there was a lot of kind of refinement.
Well, and it's a great learning ground as well, right? I mean, mapping is really the basis of everything we do geologically, right?
Absolutely,
so
you've got to think in 3D.
Yeah. So after that?
Ended up back in New Zealand working for what was then Macrae's mining company in exploration on the west coast.
Is this in noughties or
It was in mid-noughties, So our oldest son was born. We moved back to New Zealand with him. Ended up mapping in the Reefton Goldfield, and I still find my name on maps.
Nice.
But fascinating because it was attempting to put a structural framework around some of the folding there in order to try and look for the structural setting of different load structures there.
Yeah.
Which was very useful. From there down to Macrae's Flat, where there was a very large drill program just getting geared up. And so I ended up obviously having some sort of aptitude for call it then computer geology.
Right.
It was, in fact, I started with interpretation. I started with large paper sections, 2 meters long at 500 scale.
Yeah.
And basically flicking backwards and forwards through those for weeks at a time, poring over interpretation in 2D into 3D.
Yeah.
And then converting that into wireframes. So that was, the early days of explicit modeling.
Yeah.
So that was where I kind of learned to think
in 3D.
In 3D and like a resource geologist, I guess.
Right, but then up until then, the no title resource geologist, you were just a geologist modeling.
I was a geologist who got pulled into helping with interpretation. We were generating such a lot of drill results, we had to be leveraging value from those. So it was attempting to understand what we were finding, where the grade was localized, and how it fitted together in 3D.
So what was the breakthrough at that point? I mean, what clicked into place for you then in this 3D space? Was it really the tools that suddenly opened up all these doors to better interpret things, or?
Yes, in part. We, at the time, bought 3 silicon graphics workstations. So the graphic environment for what was then MineSight 3D had just developed. It was actually pre-MineSight 3D. But suddenly you had the ability to connect and draw shapes in 3D space and visualize data in 3D space.
Yeah. And from there on, it's
from there to Australia, to Sterk gold mine, where I spent a lot of time. Well, I actually had a title there, which was resource geologist.
Yeah.
So that was again attempting to converting mapping, drilling information into 3D models for planning purposes, basically, and resource quantification. Yeah. But the great thing about working underground with a mapping resource geology role is you test your hypotheses every day.
Yeah, yeah. That's it, try to break the model. So that's, So I learned a lot there, and did you end up in consulting at some stage as well?
I reached that point in your career where you realise that you're either going to have to veer into the managerial side or stay technically focused.
Yeah.
So I took myself off to Fontainebleau with support from what was MPI Mines at the time, and spent 9 months at Fontainebleau learning the art of geostatistics.
Yes. Having
been kind of mentored by various practical practitioners up to that point.
Right.
But came back with armed with some theoretical knowledge, probably a dangerous amount, I'd say.
Yeah.
Ended up in a managerial role for 15 months, and then moved to working with QG in Perth. So
right. Yeah.
With a team who were very strong in applied resource geology.
Well, that's what they're famous for, right? These were just like the best of the best, if you like, all coming together and provide that service to the industry. So obviously with the experience that you then bring to it. So how long did you do that for?
I was 10 years with QG.
Yeah.
Through surfing that fantastic wave.
But when you say never go back, but obviously QG ended up merging or being taken over by Seequent.
QG was purchased by what was Iran's Geo at the time. Iran's were at that point developing a resource estimation module or an extension for Geo, and realised that it's a domain that is specialised, that there's more at stake.
Yes.
And so they were looking for expertise and for sort of positioning and thought leadership that went with associating yourself with a I guess what was a very well regarded group at the time. That coincided with the downturn of 2015 and 2014, and things got pretty tough in the consulting world, as you probably remember.
I do remember that.
A short, deep, dark period.
Yes.
So it got a bit tricky at that point. So I actually ended up working back for Oceana Gold, which actually was very, very good.
Full circle.
It was really, 10 years in consulting, you don't get to follow things through to conclusion very much.
Yes.
So you hand across your best effort and then typically hear nothing more.
Yeah.
You can develop ongoing relationships, but you don't tend to get a chance to see how things implement.
Well, that's a good point, and I actually wanted to touch on that later in the talk, but now that you sort of mentioned it, the biggest problem as a resource geologist, you don't see them coming out of the ground unless you work as a resource geo for a big company. You see a resource coming out of the ground. But if you're a consultant, here's the resource, and good luck with it, and you don't really get to see that full breadth of the process. So that was useful then. It
was very useful to go back to that for a period of time, and particularly to work closely with the mine geology teams around reconciliation. And the linking the resource into production. And working with those teams to mentor them, it was great.
And then obviously you end up with Seequent and perfect timing in the downturn, and I guess also the right challenge at that point in time, because
the right challenge.
You can help building solutions, I guess.
Yes, I guess there's a lot to learn about the software business that I had no idea about.
Right.
But ideally we're trying to apply good science well in products that are well designed, and the whole task is to try and make the process easier for resource geologists.
Yeah. So is that sort of your role? Is there a sort of creative part of that where you as a subject matter expert, like what do you need and how do we then build that? Are you that sort of bridge between the coders and the resource geologist, or?
In part, yeah. So my title is technical domain expert geomodeling.
Right.
It's helping translate what customers need into what developers can build.
Yeah.
So I work very closely with a group called product owners, who are the ones who specify how the features should work.
Right.
So actually kind of write the specs and the requirements.
Yeah.
But helping inform that, often working directly with the developer as well, and also translating things like language. One thing I hadn't realized is that terminology is quite different in the software world.
Right. Example?
So, domaining.
The
term domaining
sure.
means different things to different people.
Yeah, right.
Compositing, same deal. It means a very different thing to a geochemist compared to a resource geologist, compared to a software engineer.
What have you learned coming out of the consulting resource geology space, and then you went to a software company and said, well, there's things that I never knew about, working in a software company. And so as end users of the software, I'm a user of the software, and there are many people listening who are users of the software. You tend to sometimes get a bit frustrated, like how difficult is it to just fix this one thing, So what are the things that we don't know, and that, from with your software hat on, you would like to tell the end users of, what are those things are?
Well, for a start, good design doesn't happen by chance.
Sure.
So UX and UI, user experience and user interface, are absolutely key to the way you interact with software, to the ease with which you can learn it, to the ease with which you can achieve your job.
Right.
And it should be almost invisible if it's done well. So that doesn't come easily. It is there's a lot of time and effort goes into thinking about the UX and the UI.
Yeah. And then people don't realize that how much time does need to go into that.
Yeah, that's right.
Yeah.
So we've even now got a UX UI lab where we can basically look at things like people's eye movements when they're using the software, how intuitive icons are to understand, all those little bits and pieces.
Yeah.
And I think that's reflected in the product. That it is easy to use.
Intuitive, right?
Intuitive.
And I was going to get to that later, but that should be a blessing, but it's heralded by some people as a curse as well, because the easier it becomes, the more danger it becomes in the wrong hands.
Exactly.
Is there anything in either the software world in general where you try to protect yourself from that view of the world, or are you just saying, look, here's the tool, I'm not going to cover how people deal with it?
You can't. People are endlessly creative in ways to use the tools you give them.
Yeah.
And so one of the things that's been interesting to me is that we started with this very strongly workflow-based approach.
Yeah.
But all of those are sets of tools that are linked together, which can be used in all sorts of different ways. So that people get very creative about use of tools in alternate ways.
Yeah.
And we often find out a bit about these uses after the fact.
And so do you then do something with that? Or have there been examples where you say, well, that's pretty clever, we need to do something with that? Or everybody's doing this particular workflow, we've got to cater to that because it's clearly a need. Do you have that sort of feedback loop system as
We
well?
do. I think one of the things that we're doing with the maturity of the product now is trying to open up the flexibility while retaining the workflow.
Right.
So rather than keeping the workflow very tightly constrained into I guess a specific use case, it's making just a bit more general and generic so that you can apply it differently.
I guess the rest what workflow is, because that's very analogous with recipe, right? And
Sure.
and you tend to, and that the whole argument against the whole issue, I guess, with the resource estimation space. And again, I'm no expert, but it's not a recipe, and this is why the codes that protect us sort of let you do your own thing, because it depends on the deposit and
it does
a bunch of things. So how much care do you put in that workflow to make sure that it's not so rigid that everybody ends up doing that? I mean, there's still some flexibility in there.
A lot, I think, is the answer.
Yeah, right.
I think the key thing to remember is that all software is a tool to do your job. And Leapfrog talking about that specifically, is a tool for building geometries first and foremost.
Right.
And geometry modeling is not geological modeling. So we have attempted to provide tools that allow you to capture the geometry of a geological interpretation easily. But it's not going to do the geology and the interpretation for you. So we've also provided tools for being able to paint the geological interpretation or control the geological interpretation with inputs.
So that's interesting because, I agree with that view. I mean, it makes a lot of sense. But if you talk about geometry modeling, sometimes when we write in our reports how we've modeled something for a client, we use the intrusion tool. But to be honest, I use it as a geometry tool because that's the geometry that I want to get out of it because it gives me the most realistic results. But people sometimes go, well, it's not an intrusion, so you can't use the intrusion tool.
That's a good idea, a good example of where maybe a workflow is a little restrictive. So I guess we have choices about what we do about that. Do we change the interface and change the name of the intrusion tool to the closed volume tool?
Yes.
Or do we rely on the intelligence of the users to actually kind of interpret beyond the fact it's just a name?
Sure.
I think probably at the base people would rather have more tools than spend effort on changing names.
Yeah, look, that's fine, but it is obviously the perception is everything, right? If it just looks like you're using the wrong tool, then it's something that I end up editing out of reports because people will walk away with the wrong impression if you use the wrong name for something. It's we're trying to achieve a geometry that maps onto the geometry of what you think you're seeing below in the ground, and whatever tool you use.
Exactly.
I don't really care as long as it comes out as something you think is realistic. So with the domaining, because I put a wee paper out in domaining because I cared deeply about this whole domaining place, and the difference, as I like to call it, between geological domaining and estimation domaining, is that something that you see a purpose to or utility to distinguishing that, or would you use the same terminology, or would you weave geometry domaining into it? How do you describe that? In my mind, quite important distinction, because a geological model is hardly ever fit for purpose to use as estimation domains. Indeed. Right? When it gets to the estimation. And maybe just to weave a second question into this, if you say, you're working in this geometry space and modeling space, then that's almost explicitly calling out that it's not the estimation space, but the tool is being used ultimately quite often for that ultimate estimation place as well, not just in the exploration space. So a lot of stuff there, but how do you see that difference sort of gelling into what you were talking about from a domaining terminology perspective?
Yes, it's a difficult question to answer. So geology, which is typically mapping boundaries between differentiable rock types, rock types you can differentiate.
Yes.
Is the core of building a geological model. And I guess if you think about a domain or a geological interpretation as opposed to a geological model, what you're taking into account of is all those other aspects that come into understanding of mineralized and describing mineralized systems. So alteration, what's driving that? Where are the pathways? Where are the structures? Where are the trap sites? How do you merge, or how do you capture boundaries between lithologies and then overlay that with boundaries for alteration, mineralization, weathering, for example. So there's, different people use different approaches and they all have their merits. So for example, in iron ore, it's very common to model 4 separate models: lithology or stratigraphy, alteration, mineralization, weathering. And then combine those. And the tools for combining them, you can just do a sort of overlay of Boolean geometries, make the intersecting shapes. The more cutting you do between surfaces, the harder that gets to manage. You can work with sort of overprinting relationships onto block models to find domains that way. there's not really an easy answer for the best way to capture that. I think it depends very much on
I guess that's
what you're trying to model.
It is, and the I always joke the only answer that we have as geologists to any question is it depends. But it's very applicable in this place. But obviously we're trying to come up with we're trying to model geology, whatever that geology looks like. But I think where I wanted to go with this, the principle of the blob and the grade shell, right? Which is the grade shell's gotten us out of kilter a little bit from an estimation perspective as well, because the software is so good at stringing things together. It's become too easy to just go straight to that grade cutoff, grade blob shell. I mean, it could still be a good blob shell, but it sort of passes the whole geological framework, and it doesn't sit in that context of the geological model. That's sort of where I was trying to go with that argument, is focus on the geology. The tools are all there, and then use your grade shells if you must to add more resolution to that.
So this gets into the very interesting kind of, I suppose, the conundrum. Should the software do it for you? Should the software provide support to help you understand how to do that?
Yeah.
But ultimately, in geological interpretation, it's a person's choice.
It is, and maybe this is a good point to sort of see what's happening out there, but there are some packages out there that through the good old machine learning try to do that cleverly for the user, and I can already see as some people call it, the wool and sock brigade, standing up and shouting like it must have the expert user. But to be honest, I've been quite impressed by the results that's been like in a 10-minute modeling exercise of something that I spent 6 weeks of building. It's like, wow. Do you see a place for that in the future? Not necessarily with either one software package or another, but just agnostic of the software itself. Is that where we will end up going in 10, 20, 30 years with computer-driven geological modeling?
So I think that you need to be very careful about framing what it is you want the machine to do.
Sure.
It's not going to do the thinking for you.
Yeah.
Machines should assist with the tasks that are boring to humans, or that are repetitive, or that are time-consuming. So they assist with speed, with repeatability, and also I think with producing uncertainty to some extent.
Yeah.
But to my mind, the most important thing in creating resource estimates is to make sure that the geology stays first. Now, your reference to the wool and sock brigades, there's a lot of people who stand up at conferences and decry the fact that no one does geology anymore. Mm-hmm. There's some truth in it. Mm-hmm. But without that geological cognitive input, you risk doing a lot of, so I guess the question is, should you inject the geological control first and then build the outputs, or should you build the outputs and look at them and think which of those is geological? Or how do you provide the geological control into that process? So I think it's been one of the strengths and the keys to the success of Leapfrog as a kind of a modeling approach is that, for one, it makes things quicker and more repeatable and updatable, but it doesn't replace, and it shouldn't replace. And I think there was some criticism of the ease with which people can build models. Now, are you criticizing the software or the person?
Or the user, for sure.
User.
Yeah, no, I mean, it's about the user, right? And we need to train the user better to make better decisions.
So if you look at the future, I think very much that it has to be driven from the basis of geology, and from geological understanding and capturing that. And I've just done an exercise where we took a set of data from a real deposit at an early stage, and through 3 different people at interpreting in order to, I guess, demonstrate, the strength of alternate hypotheses. And the hard part is not building the geometries. The hard part is the cognition of looking at and understanding it and thinking about what's going on, understanding the controls and how you build that.
Well, that might be something to maybe expand on a little bit, either for the company or just in general, right? Because there is that famous paper where they've asked, I don't know, 40-something geologists to build a resource model, or just the domains, I can't really recall. And they looked at the different and the variance in the outcomes, right? And obviously to prove the point that it can be quite varied. I mean, I think that paper was quite a while ago. I don't know if you know about it, but I think it was, I want to say 20, 30 years. I'm sure somebody will correct me in the comments.
There's two papers there. There was a paper where a lot of people were given the same data and asked to produce a variogram from it.
Yeah, no, that
varied. And there was a paper that Scott Jackson was the key author of. I was one of the co-authors. From Stall, where we took only 3 interpretations. Or 3 geologists, sorry.
Yes.
This was searching for, we discovered the offset of the Magdala ore body below a structure called the South Fault into what was called the Golden Gift.
Right.
Since now gone.
Nice.
And at that stage, there was a lot of uncertainty about what might be there, might it look like. And so we took the available data, gave it to 3 different geologists, and the interesting part was that it was kind of hard-bitten mine geologist at one end, blue eyes exploration geologist at the other end, and the resource geologist, me in the middle.
I haven't seen that paper.
I'll flick you a copy. It's surprise, the most optimistic was from the blue-eyed exploration geologist. The most pessimistic was from the hard-bitten.
Well, that's their job, and that's their job. So, maybe we can expand on that principle, right? Because with the software now, how good would the exercise be to indeed grab a mine site with a lot of data, grade control data, good geology, and there's plenty of good examples, right?
Yep.
And I'm sure they'd be happy to have that data in the public domain to some degree or whatever, and then literally do an open source, because a lot of these projects in the last 10 years, right? These contests and competitions of prospectivity mapping, like the one in Canada, you could probably open source 100 different inputs and get real, and give people a week free license to build a model for it, something like that. That would be fantastic information for a company to play with.
It's great information. I think. It sort of comes back to where the biggest leverage for uncertainty is.
Yeah.
And it's almost always with the fundamental geological interpretation.
Well, that's exactly
depends
right.
It depends on project scale, where you are in a project. Obviously, over time, you settle into a framework, and the more holes you drill, the more you test your hypothesis and don't confirm it, but you don't refute it.
Yeah. Well, did you see the paper from Scott McManus, I think, on capturing uncertainty in geological domaining? I think it came out at the last mining geology conference, and there is a move into that general uncertainty capturing that is really quite interesting, because, as you say, you build, generally speaking, especially if you're a consultant, you build one model, you don't get paid to build 20, to play around and build variants of models. But now the JORC will soon have us put more pressure on discussing risk around various aspects and uncertainty and all these things. So how do we capture that? And are we getting to a point where we can, click one button and, the uncertainty of your geological model is 55.3%, that'd be quite exciting.
I think you have to break uncertainty into types that are that can be quantified using existing tools, and types that are basically a fundamental choice. So whether there's a fault through here is actually a choice. So the impact. So to my mind, the most important thing is actually to provide tools around the sensitivity of the outcome, the sensitivity of the estimates to those differences. I mean, it's one of the reasons I think that it's perhaps one of the things that's still underutilized in Leapfrog is that the ability to create alternate interpretations easily. My experience is that you actually need to use different people.
Yes.
You need a team of people to do it, because if you once you've invested effort in understanding or building a geological concept in your head,
you're biased.
And it's very hard to let it go. Consciously.
Look, it's a great comment, because we internally we have that process, because you're supposed to comment on this, right? Are there any other possible models? And look at all these public reports and say no, there aren't.
Exactly.
crap. Of course there are, and if you, but you can ask your colleagues. But again, they don't have the same. I mean, an internal peer review fits in what you do for a client. That's a day's worth of work, and it might say, oh, I might put that fault here and there, but you don't have the time to quantify that. So what I end up doing if I'm building a model, I indeed, try, to be not biased and build different grade shells, different geological decisions in terms of the faults or whatever it might be, and have all of those run through, because that's the power in my mind of Leapfrog, right? You can have all of that running through to the end grade tonnage curve, and if all of those are sitting on top of each other, then I feel I can write that line in the report quite comfortably, even though you still have that cognitive bias in that place then. But
one of the things I think you have to be, it's tempting to think that, geological uncertainty is the big nut to crack. Stochastic uncertainty around things like grades, the tools have been around for a long time. We just need to democratize them, make them easily accessible and usable, and work backwards from the answer the problem you're trying to solve with that uncertainty. But geological uncertainty is much harder to quantify, given that typically we want unique outputs. We want geometric representations of that geometry or the geological interpretation. But the big challenge there is that the geostatistical tools or the stochastic tools around uncertainty just produce your strings of sausages. You have well-controlled points around data and high uncertainty in between. Well, so what? You know that.
Yeah, you know that. Yeah.
So the real question, and there's a kind of a school of thought which says that, well, I take my geological model and I flex the parameters that I've used to build it. There's nothing objective about any of those parameters. They're practical. They're things that you choose in order to have the geometry built in a way that represents your imagination.
Exactly. Yeah.
So flexing those it's a kind of a dead end. I don't think there's any merit in that.
No, look, I've been guilty of that. Indeed, you have settings with a thinner ellipse and a wider ellipse and a this and a different direction and all the rest of, just to be able to say, look, I've tried to see if that generates something that doesn't map onto what I think in my head. And that's why I've chosen this one. But in any case, if it would be that, then there's no difference in the grade tonnage curve anyway. Therefore, risk is low, something along those lines.
That's what you want to know. But I think you should be very careful about geologists in general should be very careful about thinking that you're going to be able to create a distribution of uncertainty.
Sure. No, look, we're not a couple of months away from that. That would be the holy grail, right, of domaining and geomodeling.
And I think it is. We're putting thought into what that's going to look like. It seems machine learning has a part in that.
Well, I think so, but obviously, like you said, the machine needs to be trained on something. And I've been talking about this subject with several people for many years, and every deposit is different, obviously, and even subtle changes could steer a machine in a completely wrong direction. So it'd be very hard with data being locked up and so carefully owned by companies. I mean, if we
have very sparse data. Geological data is extraordinarily sparse.
Well,
so we're doing a lot of work between the data points, which is it's all that sort of work.
Well, the discussion that I had, this is about 5 years ago now, but you could have a whole bunch of mines with a lot of grade control data, right, where you have at least those estimation domains, if you want to make that distinguish, captured with a geometry that matches some style of mineralization. If you would, for instance, in the more tricky ore bodies to model, structurally controlled gold ones, have 200 geometries in such and such settings. Look, I don't think it's going to work, but at least you would be able to train the machine on something, right? I mean,
it's tempting to look at templates based on existing. So, share zones, share hosted deposits they share characteristics.
Exactly.
But they're all different.
They're all different. Yeah, exactly. So.
And you have 200 when you find the next one and describe it, you'll have 201.
Well, what I did find interesting, indeed, it's how you use the software, right? And this will be the same case if at any point in the future we have this solution. All it really does is nudge you in the right direction. Yeah. Because when the structural what's the tool again? But it creates this isoplanes.
Form lines? Or
yeah, the
structural
form
trends?
lines. Yeah,
Yep.
when that came out and you could just put your structural discs in, I remember modeling a deposit and not really quite seeing it. And I just put the structures in, let it just create these planes, put a filter on whatever particular, you know, and it popped out and it's like, huh, that's cool. And it actually turned out to be exactly, well, you know, after it was all drilled out, you know, the geometry was just, and that, so that's probably the first time where I thought, you know, there's clearly something that the machine can do given a certain amount of conditions and input that trigger something in you. So it's all about, you know, it will never, the computer will never build the final model that you end up using for estimates, but it will get you very far, and so that you only have to do the last bit of heavy lifting, something like that. Don't know.
I think in the future we should be providing tools that help you interpret the data,
better,
interpret that in terms of geology, and then build surfaces that reflect that interpretation, that understanding. You know, it actually takes us back full circle.
Yeah.
That there's the old adage that, you know, the best geologist is the one who's seen the most rocks.
Yeah.
Well, the best resource geologist is the one who's seen the most patterns from existing deposits, because it dictates what your imagination can conceive of.
So is that, and then indeed going full circle, is that why it's so important to have 10 years of consulting under your belt? Because that's really the only time when you have that exposure, but you also need to sit in a mine environment where you need to see it come out of the ground. And just to turn it into a question, if you combine those two requirements, it's pretty damn hard to find people who tick all of those boxes, having seen, what was Jackie looking for, 5 deposits mined and reconciled or something, for you to actually have that feedback loop in your head to know that your models are, I mean, that's not easy if on top of that you also need to have modeled, I don't know, 50 or 100 or 200 different deposits.
I mean, I hate to say it, but I fear that's true.
Yeah.
That I think there is no substitute for experience.
Sure, but that would only leave 50 or 100 resource geologists left, right?
It's a problem that the industry needs to address, is how we ensure that we retain that level of that we develop that level of experience and expertise, because the machine is, you can counter lack of experience with lots of data.
Yeah.
But there's also pressure in the opposite direction for lots of data. People want to do more with less, not more with more.
Well, I mean, so this is actually an interesting point to me, because I like, the education space, I guess. I mean, it's very nice to share what you've learned with others, and hopefully it's the right thing, right? And then with this resource geology discipline, I talked to Eric Ronald about that very briefly. I don't know if you watched it, but there is a discussion about, look, where do you learn this stuff, right? Because there are obviously the books, right? And there's a few here, and you can. But if you pick up Clayton van Deutsch's book, you know, if you're not into that mathematical space, which a lot of geologists aren't, because they study geology because that necessarily wasn't their strongest suit.
Exactly.
They want to be outdoors. They don't like the numbers. I mean, good luck with that book. I mean, it's a great resource if you've done the Fontainebleau thing, or in Adelaide or various other studies. So the question is, how do we teach that? And then I guess the follow-up question would be, that's the estimation side. But as I quit with Ronald, where's the book on domaining? Somebody show me the book on domaining, because all of that is just word of mouth from one person to the next, and it's so loose. I mean, pick up any course with any consultant. There's one slide like, here's a couple of domaining missteps, but let's talk about sampling, QA/QC, and the kriging matrix, right? I mean, how do we tackle that one then?
It's a really thorny question for the industry. I don't know the answer to this one. I wish I did.
Of course, that's why we have you here.
You'd know from your own experience that the appetite for in-person courses has just evaporated.
It has.
People want to learn online. They want much shorter courses.
Yeah.
I think there was huge value in those industry short courses, because they were, as much as anything else, listening to stories and going off on digressions and talking about things like domaining practice and war stories. And unless you sit down with somebody, you don't get that. So I think companies have a role in terms of nurturing teams. And there are some good examples around of strong resource teams inside of company environments.
But they're the bigger companies, right?
The bigger companies, that's right. And it's difficult for individuals to receive that level of mentoring. I think one of the things that we should, well, maybe companies should be doing is involving, well, basically the audit/review process, using it more rigorously. So if you prompted me with a question earlier about avoiding geological disasters that affect companies and share prices and individuals. And part of that is because there wasn't open transparency around, that basically there was too much emphasis placed on a single interpretation by a single person without sufficient review. And that if companies are honest, they should be, and I don't know whether you mandate this inside of a code, potentially, but it becomes difficult. As soon as you put boundaries and rules, then these things get difficult. But it sort of comes back to the role of what a board should be requesting from and requiring from resource estimates, particularly when there is capital decisions going to be made on it. Maybe a more rigorous review process is the way to go.
Well, I find it really difficult, because if you weave this into the whole JORC debate now, and arguably some of these disasters or train wrecks or whatever you want to call them being linked to, the resource geologist, I take issue with parts of that. Some parts I see, because it isn't always great what the industry puts out, because like we said, how many people have truly seen 100, how many people have seen reconciliations of their resources in 100 different models and all the rest of it. So can you blame them if we allow that to happen?
No, we put them in a situation where you don't know what you don't know.
So education, and funnily enough, that's sort of where we landed on with Eric as well, and why he does what he does on Friday, Geology Tips, right? It puts it out and we share. And maybe we'll land on this here as well. I don't find that the books necessarily make it easy for you, although, and full disclosure, I'm a big fan of Jackie's books, because they as I said in my previous podcast, they dumb it down for dummies like me to understand, what at least the geostatistical side of it means. But then it doesn't really cover the domaining side, and coming back to Seequent, I mean, isn't there a beautiful space to step into and actually educate at the same time of bring the solutions to place? Or should it be the institutes, or should it be something else?
I don't know who should drive it. I agree with you. I think there's a wide open space there to occupy. I mean, it's not a software company's sort of bread and butter. It's a business, and you're making money out of selling software.
Well, because if you look at, sorry to interrupt, but if you look at the actual disasters that we know of, and we probably second guess as to what really happened, but I mentioned the Rubicon one in a previous video, and at least we have some idea that had to do with domaining.
Yes.
And it is my belief that most of those big, I mean, it's not going to be the variogram or the minimum amount of samples that you use, right? It's going to be that categorical misrepresentation of the domains that turns it into custard. Absolutely. So, the statistics books probably cover a small part of the train wrecks. Because I was just talking to Steve Hunt last week, and there's this resource with an inverse distance with a power of 0.1 that was put out to the market, right? I mean, there's clearly things that we can get rather wrong there, but it's more the exception than the rule. I think the domaining is really where a lot of solutions lie. So
absolutely agree.
So big responsibility, Mike.
I think there is a lot of value in it. It's hard work producing that sort of material.
Sure.
And no one, people don't make money out of writing books anymore.
No, well, there's that too.
You don't make money out of selling online content.
Or courses, right? I mean, that's the thing for Seequent. There's obviously zero reason to go in there. And like we said before, if people use the package and they misuse it, it's not necessarily their problem. So it would only be, just an altruistic sort of component that you try to improve things, which is for a company with shareholders hardly the place to be. So it's
exactly. And universities are probably not going to go into that space either.
No, well, they're only they're crumbling down around us, the universities, right? I mean, this is a whole different discussion. Probably need to grab another beer for that one, but. I don't think the universities fill that space at all, or will be filling it.
No, I don't think they will. I don't think there's any driver for them to.
Yeah.
So should the industry set up its own university, fund its own university? I think there's some merit in that.
Yeah.
I think there was huge value in the short course space.
Yes.
Or the industry course space.
Yeah.
but that is
interesting.
The world is shifting, and
it is.
It's partly to do with how people want content delivered because of the lifestyles we give them.
You're not wrong. I mean, and this is what obviously we're sensing in the industry. If I put my Ausm hat on briefly, you can sense that whole education space is changing. How we communicate with each other is changing. So I'm sure that hopefully the solution will come out of that space. But it's interesting to link it back to those software companies. So I really appreciate that sort of that line into this equation. Maybe just about Edge, that's all the domaining stuff, but Edge, the resource estimation, crunching part of the software. When it came out, I was like overjoyed because you can do everything in one package and you don't have to import and export and all that sort of stuff. It's been on a bit of a hiatus. I mean, as a resource geologist, there have been some improvements, but what can we expect in that space? If you're talking about all this domaining, which is great, can we expect anything in that space, or improvements or further thoughts?
Yes. So this actually leads back to one of your earlier questions about what people don't know about software, is that it is time-consuming and expensive.
Yeah.
And so, we're always resource constrained. So, our backlog list of ideas of things that people would like in software is, it's vast.
Yeah.
So prioritization is always a delicate balancing act.
Yeah.
That said, we try and work in themes. One of the themes is around resource estimation and improving that. So part of that is increasing the flexibility of Edge for larger and more complex estimation tasks.
Yeah.
So to make it easier to create and manage bigger estimates.
Because that's sort of the die-hard estimators, they're craving that sort of additional functionality and not.
They love their scripts.
Yeah, the scripts. That's right. Yeah.
So one of the areas we're pushing into is, as a software company, is the providing software as cloud services.
Yeah.
And providing connectivity through call it a platform. So that in the future you don't try and create a piece of software which is all things to all people, because it's a hiding number. You're not going to be able to do it.
Yeah.
So the way to get that flexibility is effectively to open up the access to it through providing easy mediated data access and outputs access. Yeah. So being able to push data into the cloud to run cloud native geostatistical solutions for things like simulation, which are crunch heavy, or for third parties to be able to write their own algorithms.
Yeah.
So the beauty of that is that you are no longer trying to ensure the security of the data security of software packages, which is hard, and you're effectively providing kind of a gate through the APIs, which is a far more rigorous way of ensuring that security.
Yeah, well, that's exciting, because that's really where the future lies, obviously, and that maybe brings us back to that comment as well. What people don't know. I mean, it must be, as you build your software, in the early days, you don't know what you don't know, but you need to put an infrastructure in place that is going to carry everything that comes beyond it, right? And 30 years from now, as many other software packages have found out that started in the 80s and are now trying to remodel based on what's happening out there. I mean, again, I don't know, so I might be getting this completely wrong, but I'd imagine that they sit around the table and they say, we want to change this, and the engineers say, sorry, I can't do that unless you hack the whole thing to pieces and start over again, right?
Exactly.
So, and that costs money and time and planning and all, Have I got that roughly right? Or?
You've got that precisely right. That you once you embark on a path, then software has a lifespan, effectively.
Yeah.
Now, particularly for a dynamic software like Leapfrog, where there's so much interlinking in from the data through to the outputs, which means that every time you touch anything, there's a mammoth matrix of testing to ensure that it doesn't break something else that you hadn't considered. So when you have individual standalone executables, and you kind of you're running basically a sort of a collection of executables jammed together into a package, you don't break things so much, but you have very little flexibility.
It goes hand in hand. So if you want flexibility, everything hangs together, and every change that you make requires, you know, a huge process. Yeah, interesting.
So what we need to do is I mean, what we need to do with that is ensure that the core technology, the immersive modeling experience of actually building 3D geometries is something that the desktop is very good for. And so we need to basically play to those strengths and continue developing that capability. But the peripheral stuff like data ingress and egress, you know, you don't want to support a million import and export, as many formats as there are different other packages in the market. There's no profit in that because there's just becomes a huge maintenance burden trying to keep those up to date, ensuring that someone doesn't change their format and break your importer or exporter. So you want to shift those to the cloud. You want to have the data sitting in a neutral zone and write the importers exporters once.
That's fascinating. I mean, it must take an incredible amount of sort of senior architecture planning that you know, you don't just walk into a boardroom for an hour and draw a few lines on a whiteboard. It must be really quite intricate.
And it's continuously evolving, and you're continually obsoleting yourself. So you don't get it right first time, but you have to start.
Well, that's the other thing.
Just make sure you don't paint yourself into too many corners.
And you have to push it out as well to get some early feedback, because if you try to, don't let perfection stand in the way of progress, because if you're trying to perfect it, then others will surpass you, or people lose interest and go somewhere else. There must be a balance there, like, you know, folks, let's get this out. And you know, we'll let the feedback come to us, right?
You also have to be having your eyes on a number of horizons. So in terms of planning as a company, we have a kind of a horizons planning framework. And so, you know, horizon 1 is what we know we have to do to basically service our existing business and to let it grow. And then beyond that, we're looking further out to the point where, you know, I guess we should be trying to obsolete ourselves. So the long run is let's do modelling in a different way with a package which is going to supersede.
Well, that's maybe a great place to finish, because, you know, that's the future of modelling, and I wish we should put a crystal ball on the table here. You know, that would be quite applicable for our industry, I'm sure.
It'll be quite cloudy.
It'll be quite cloudy, and we can work out what's going to happen. But no, look, really fascinating. Anything else that you think is, you know, relevant to this sort of topics, or these topics that we covered, or?
I mean, I'm very passionate about the idea of geological education, and contextual education that lets people do the sort of jobs they need to do. So how we provide it, I think, is so open at the moment. You know, part of the value of running things like industry short courses or preparing material is that it's not until you have to teach it that you truly understand.
Well, that's absolutely right. And obviously I had the luxury of presenting some of the courses with Seequent on Introduction to Resource Estimation, and you don't want to be standing there and not know your subject matter, because that is can be quite embarrassing.
Absolutely.
But I think we share that common goal, and look, we're developing a few things in-house here that touch on this as well. You know, I've been talking to some other people. I mean, Jeff's book is on the desk here, Education in the Sampling Space. You know, because there's obviously, I mean, you haven't touched on data yet, and sequence, you know, MX deposit, and how we integrate QA and QC into that. I mean, there's probably a whole world of
absolutely. Well, think cloud. Cloud is the future.
No, but that the cloud is the future is absolutely.
There's new strings of satellites going up all the time, so connectivity anywhere on the planet is becoming a non-issue.
Well, that is certainly going to be a benefit. So now, look, fantastic. Well, nice to have you in the studio. Really good to talk to you. So
very much enjoyed it.
Shall we go and grab a beer now?
Let's go and grab a beer.
All right, fantastic.
Great.
Thanks, Mike.
Thanks, René.
Cheers.
Cheers.